For today's lesson, our focus standard is Grade 8 Expressions and Equations, Topic A, Standard 1. Know and apply the properties of exponents to generate equivalent expressions. Our topic is exponents, a power raised to a power. And our essential question is, what is the pattern when using an exponent on a number already in exponential form? So please take a moment, pausing the video if you need to copy down the header and set up your question column and your note column, and resume the video when you're ready to begin. So it's important to note, if you haven't picked up yet on this in the previous two videos, that we can also use power when talking about exponents. So another word for exponent is power. And we will sometimes say that the base is raised to blank power. So for example, if on the base number we have an exponent of 4, we would say that the base is raised to the 4th power. Or if on the base number we have a 6, then we could say that the base number is being raised to the 6th power. So again, this is referring to when we are using exponential form. So today we're going to look at a number that is already in exponential form, but it has an exponent on it as well. And again, we're going to see what can we do, or what patterns emerge to take a problem like that and simplify it back down to one number in exponential form. So let's go ahead and get started. So here's our first problem for today. We have 3 to the 5th power in parentheses, and we're raising that to the 3rd power. So our goal is to see how can we rewrite all of this so that we just have one value in exponential form. And so to do this, we want to first break down, well, what does this mean? So it wants us to take this group here, 3 to the 5th, and multiply it by itself 3 times. So that would look like 3 to the 5th power times 3 to the 5th power times 3 to the 5th power. So there we've started to expand it. And so that would help us determine what this exponent of 3 means. But now we need to expand this out further because we still have exponents. So we can say, well, I know that 3 to the 5th power means 3 multiplied by itself 5 times. It looks something like this. And because we have 3 groups of 3 to the 5th power, they're being multiplied by each other, this 3 to the 5th power is represented here. We're going to multiply that by 3 to the 5th power again, so we can expand that out. And we're going to multiply that by this 3 to the 5th power, and we'll expand that out. So using parentheses to help us keep track of our groups, here's our first 3 to the 5th power multiplied by our second 3 to the 5th power multiplied by our third 3 to the 5th power. So in this expanded form, now that we've been able to expand it out and get rid of all of our exponents, we can see, once again, we end up with just 3 being multiplied by itself repeatedly with no other operation. So how could we write this in its fully expanded form to being one value in exponential form? Since it is the 3 being multiplied by itself repeatedly, 3 is our base number. What's our exponent? Well, we have 5 3's, and then 5 more making it 10, and 5 more making it 15, so we have 15 3's being multiplied by its all together, so it becomes 3 to the 15th power. Let's take a look at another. For our second example, we have 6 to the 2nd power, all raised to the 4th power. So we're going to do it just like we did in the first problem and try and expand it out one step at a time. This 4 outside of the parentheses means we want 4 groups of 6 to the 2nd power being multiplied together. So here's our first one, 6 to the second power times 6 to the second power times 6 to the second power a third time, and 6 to the second power a fourth time. So there are the four groups. So that would take care of this one. Still not fully expanded though, so we still have exponents, so we want to expand them out further. So 6 to the second power is 6 times 6. There's our first one. There's our second one. There's our third one. And there's our fourth one. So now it's fully expanded. 6 to the second power raised to the fourth power, and it looks like this. So what is this going to simplify to in one value written in exponential form? Since 6 is being repeatedly multiplied, 6 is going to be our base, and it's being multiplied by itself 2, 4, 6, 8 times. So our exponent is 8. So 6 to the second power raised to the fourth power becomes 6 to the 8th power. Let's try another one. This one looks a little different. I've raised the challenge up a little bit to show us that we can do this with numbers written as fractions as well. So we have 5 to the second power in our numerator and 7 to the second power in our denominator. Let's expand that out. What is 5 to the second power going to look like when we expand it out? And what is 7 to the second power going to look like? If you said that we were going to take each of those base numbers and multiply it by itself twice, I'd agree with you. And you would end up with something like this. 5 times 5 to be 5 to the second power in the numerator, and 7 times 7 to represent 7 squared in the denominator. So we're seeing repeated multiplication, so how could we write that in one simplified exponential form? Since it's 5 to the 7th that's being repeatedly multiplied, we can keep that as our base, and it's being multiplied once and then twice. So instead of having it written like this, both with using the exponent of 2 twice inside the parentheses, we can pull it out and just use it once outside of the parentheses. So 5 squared divided by 7 squared could be simplified in exponential form to be 5/7 to the second power. So with these three examples, I'm wondering, just like we did in the last video, is there a pattern, or can you see, is there a trick or a shortcut to go from this, where we see a power being raised to a power, 3 to the 5th power being raised to the 3rd power, and jump from there to the answer of 3 to the 15th power, without having to expand it every time? So take a look, especially examining these first two examples, to see if you can figure out what you think the pattern is. And go ahead and record that down below our work. What do you think the general rule is when raising a power to another power? Record your thoughts and come ready to discuss that in class. Before you conclude this video, please make sure that your header is fully complete and that you have all of the notes copied into your math journal, and of course, that you left room for the summary.